The binomial theorem. You're probably pretty fast at expanding or foiling something that looks like this, x plus y squared. You know, you write it twice, and then you foil it, and hopefully you can do the outside and inside together in your head, so that would be x squared plus 2xy plus y squared. Now, if we had x plus y to the third, that would take a little bit longer. We would have 3x plus y's. And you know what the two of them come out to be, x squared plus 2xy plus y squared multiplied by x plus y. So you would have to take the x times all three, the y times all three, combine like terms, and so on. And that's going to take even longer. What if it was x plus y to the fourth or x plus y to the fifth? So there's actually a shortcut to doing problems like these, and there are two different shortcuts. One of them is the binomial theorem, which is the title of the lesson, but the first one we're going to use is actually called using Pascals. This is an example of Pascal's triangle, and using it to expand binomials is one of the many uses it has. There are multiple patterns buried inside this triangle used for different things. But if you want to pause the video and look at the triangle and see if you can figure out how it's created, that's what I would have you do in an actual classroom. So pause it now and think about it. Okay, let's see if you figured it out. So it starts at the very top with a 1, and then two more 1s, and then you add the two numbers to get the one below it. 1 plus 1 is 2. And then for the next row, I would add 1 and 2 and get 3. 2 and 1 gives me 3. The next row, 1 and 3 gives me 4. 3 and 3 gives me 6. 3 and 1 gives me 4, and so on. And notice that every row always starts and ends with a 1. The way the rows are numbered is the top row is actually row 0, and then row 1, and so on down the way. So these numbers will be the coefficients, the numbers in front of the letters as we expand these. We want to expand x plus y to the fourth. Since the power is 4, we would use the fourth row of Pascal's triangle. So that would be this row, 1, 4, 6, 4, 1. And you start, the first coefficient is a 1, and we don't actually have to write a 1, but you can think of it being there. 1, x to the fourth, the original power goes on that first variable. Then plus, then I go back to the triangle, the next number is a 4, and I have x, it drops down a power, and the y comes in for the first time. Then plus, next number on the triangle is a 6. The x drops down a power, and the y goes up a power. Next number on the triangle is 4. The x drops down a power, the y goes up a power. And then the last number in the triangle is a 1, which we don't need to write. The x is gone now, and the y goes up a power. So whenever you check it, the exponents on your variables should always add to equal the original. So I have an x to the fourth, and then x to the third and y to the first. 3 plus 1 is 4. The next term, 2 plus 2 is 4, and so on. So the exponent should always add back to the original. So all the problems follow this pattern. The numbers in front, the coefficients, come from the triangle. The first term in the parentheses begins with the original power and goes down a power every time. So that would be the x. It starts with the highest power and then goes down a power until the last term it's gone. The second term in the parentheses doesn't appear until the second term of your expansion. And it will start with an exponent of 1 and go up a power each time. Let's try one that's a little bit more. 3x minus 2 to the fifth. So we'll need to use row 5. One, 5, 10, 10, 5, 1. And we'll start with a coefficient of 1. And my first term, 3x, is to the fifth power. Put it in parentheses, because not only will x be to the fifth power, the 3 will be also. Plus, and then from the triangle I have a 5. My 3x goes down a power, and my negative 2, the negative goes with it, comes in for the first time. Plus, The next number on the triangle is a 10. The 3x goes down a power, and the negative 2 goes up a power. Plus another 10. 3x goes down a power, negative 2 goes up a power. Plus, from the triangle, a 5. 3x goes down a power, negative 2 goes up a power. And finally, we end with a coefficient of 1, which we don't need to write. The 3x is gone, and now negative 2 is to the highest power, to the 5th. Now you'll multiply everything that's in between the plus signs. So 3x to the 5th, you'll expand that out. All of this, 5 times 3x to the 4th times negative 2, multiply all of that together. Everything that's in between the plus signs gets all multiplied together. And so when you do that, you end up with 243x to the 5th, and then it's a negative, because of the negative 2, 810x to the 4th, plus 1080x cubed minus 720x squared plus 240x minus 32. So everything in between the plus signs, everything I've underlined in red, all gets multiplied together. And so you have a result that's much faster than if we'd written 3x minus 2 5 times and had to multiply all of that out. Sometimes in your homework you may have a problem that doesn't have any variables at all, and that's okay. Just be careful about, you have a homework problem where square root of 2 is one of the terms. So be careful when it's raised to a power. For example, square root of 2 to the 4th. That would be 4 of these. And every time there's 2 of them, a 2 comes out. So square root of 2 to the 4th would be 2 times 2, which is 4. Square root of 2 cubed would be square root of 2 times square root of 2 times square root of 2. So 2 of them together, a 2 comes out, but this last one is by itself, so you would end up with 2 square root of 2. So it gets a little bit messy, just be careful. Cut for expanding these binomials is the binomial theorem, and it's a formula that uses something called the binomial coefficient. And we're not actually going to end up using it in the formula, but I still think it's a good idea for you to see it. It comes up sometimes in probability and statistics, which may be something you have to take in the future. If you've never seen in math the little exclamation mark, that's called a factorial. And it's easiest just to show you an example so you see how it works. For example, if I have 5 factorial, that means 5 times 4 times 3 times 2 times 1. If I had 7 factorial, that would be 7 times 6 times 5 times 4 times 3 times 2 times 1, and so on. And so we're going to evaluate. We have a 6 on top, that's the n, a 4 on bottom, that's the r, and we'll fill it in the formula. 6 factorial over 4 factorial, and then 6 minus 4 is 2, that's the n minus r, 2 factorial. So 6, 5, 4, 3, 2, 1 on the top. On the bottom, 4, 3, 2, 1, and then 2, 1. And then I can cross out the 4, 3, 2, 1. I can divide 2 into 6 3 times, and we end up with 15. So like I said, even though that's part of the binomial theorem, we're not actually going to use it for that, but this might come up again in some other course that you have, and it's a good idea to see what factorials are. The difference between Pascal's triangle and the binomial theorem is how we acquire the coefficients. So Pascal's triangle gets them off of the triangle. The binomial theorem will do it another way, but the way we take the first term to the highest power and that term goes down 1 each time, the second term comes in the second time and that exponent goes up 1 each time, that's going to stay the same. So the formula actually is more complicated than it's worth, in my opinion. I think you'll catch on if you just watch. We start the same way we did with the Pascal's triangle. My first term is x to the highest power. Plus, now I don't have a triangle to get my numbers off of. I write down my highest power and put it over 1. And then it's x goes down and the y comes in for the first time. Now for my coefficient, it's 4 times 3 over 1 times 2. The x goes down a power, the y goes up a power. Then it's 4 times 3 times 2 over 1 times 2 times 3. You see how what's on top is going down and what's on bottom is going up. The x goes down a power, the y goes up a power. And then we have 4, 3, 2, 1 on top. 1, 2, 3, 4 on bottom. X is gone. Y to the highest power. Now you're going to have to simplify all those little fractions. You can cancel stuff out, like on the second one, 2 goes into 4 2 times 3 is 6, and so on. So when you simplify down all those fractions, you end up with x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. I guess the advantage of this method over the triangle is you don't have to draw out a triangle. Let's do one more, 2x minus 4 to the 5th. So all of 2x in parentheses, hang on, my thing's not cooperating. All of 2x is to the 5th power. And then I write my highest exponent over 1. 2x goes down a power. The negative 4 comes in for the first time. And it's going to be 5 times 4 over 1 times 2. 2x goes down a power. Negative 4 goes up. 5 times 4 times 3 over 1 times 2 times 3. The 2x goes down. Negative 4 goes up. Notice my exponents are adding to 5 every time, just like they should. 5 times 4 times 3 times 2 over 1 times 2 times 3 times 4. 2x goes down a power. Negative 4 goes up. And finally, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5. That last one will always all completely cancel out. Top and bottom. 2x is gone, negative 4 to the 5th. So again, everything that's in between the pluses all gets multiplied together. You probably want to simplify the fractions first. But everything in between the pluses all gets multiplied together. And what you end up with in the end is 32x to the 5th minus 320 x to the 4th plus 1280 x cubed minus 2560 x squared plus 2560 x minus 1024.